Hi, welcome to my channel. I hope you're well. In this video, I continue my series about how to create a simple role-playing game using Python and Pygame. In my last video, I introduced a passive NPC and walked through how to get into a fight with it. Well, as you will see, I've made a few changes to the program. In this tutorial, I will first give an overview of the program. I will play through the game, such as it is, and talk a bit about game mechanics. Then I will look at code and discuss how I have restructured the program. I'll also go over maps I've made that I use to create the visible game world. Next, I will introduce 3 new classes tied to this new environment: actions, triggers, and events. Then we will look at how the player can interact with his environment, what objects he can manipulate. We will also look at how to create and train a dragon, an NPC dragon. I will step through the code I used to create an aggressive NPC, one that runs up to the player and picks a fight. Finally, I will explain certain aspects of the code I used to have a conversation with the NPC, Old Ben, in the first zone. There are a few other things I will touch on briefly, but that's the itinerary. In the next tutorial, I'll introduce you to the Town of Swindon. There, you will be able to buy goods from NPCs as well as sell to them. You will also be able to accept and turn in quests. At least that's the plan. First, an overview of the program, playing through the game. As you will see, I've completed the first 2 zones, though I haven't implemented levels or experience points. The way the program is structured, you shouldn't have any trouble doing that on your own. I anticipate implementing levels and keeping track of experience in a future tutorial. By the way, tell me what you would like to see in future versions of the program. The zones we will be looking at today are called Dark Alley, Green Lawn, and Swindon. Dark Alley and Green Lawn are complete, but Swindon, a town zone, is just a stub. At the moment, there is no character creation dialogue. That is another thing I would like to add in the next version. You will be playing as a character named Henry. In a future version, you will be able to select different names and character models. So, beginning the walkthrough, let's look at the zone Dark Alley. We start off the game with our avatar waking up and having a flashback. He gets up and stumbles toward the end of the alley, toward the light. Henry notices a lamplighter at the end of the cobbled lane. By the way, note that there isn't much for Henry to do at the moment other than talk to the lamplighter. This is by design. I wanted to make sure the player's character talked to the lamplighter because the lamplighter needs to tell Henry to go find Lily at the pub in Swindon. The information about Lily is contained in the last element of the exchange Henry has with the lamplighter, so the player must finish the conversation to get at it. But the conversation isn't easy to finish. The lamplighter is grumpy and very handy with a knife, by which I mean there are 3 conditions: continue, end conversation, and end game. And each step of the conversation, there is generally only 1 chance to advance. There is 1 chance just to end the conversation and 1 chance for the lamplighter to kill the player. After Henry finishes his conversation with the lamplighter and takes a couple of steps, he walks over a trigger. The trigger determines whether Henry has successfully completed the conversation with the lamplighter. If he has, then a previously hidden area of the map is revealed. In the new area of the map, we see a courtyard and what appears to be a body lying in a pool of blood. The player goes to investigate, and after searching the body by pressing the H key, he finds a gold ring. Now that Henry has the ring in his inventory, when he walks through the arch back to the cobblestone way, a portal is revealed. Henry walks up to the portal, presses H to interact with the object, and is transported to another zone. Zone Green Lawn. I'm calling the zone just completed Dark Alley, and this one Green Lawn. Here you see a green field. There are also trees and strawberry plants. Let's talk about the strawberry plants. Every plant is implemented by a class I've called class actions. We'll take a look at that class in just a moment. When you go up to a strawberry plant and interact with it by pressing H, an item is put into the player's inventory. In this case, the player could receive a few wild strawberries or a red amulet. Also, other elements of the environment can be changed by interacting with a strawberry plant. For instance, a dragon could spawn. By the way, this dragon is immensely strong and unkillable. If the dragon catches Henry, he will die. If Henry tries to jump through the portal on the right, he will only succeed if he has the red amulet in his inventory. If Henry runs to the portal on the left, he will be taken back to the beginning of the zone. In that case, he would have the opportunity to search for the red amulet. Fortunately, it is easy to outrun the dragon and be the first one to the portal. If on your machine it is difficult for Henry to reach the portal before the dragon, just adjust the amount of time the program sleeps each tick. The final zone is Swindon. When Henry emerges from the portal, he is just outside the town of Swindon. As you can see, the town isn't finished. The version of the program I've uploaded to my GitHub is my current working version, so the Swindon zone won't do much. If you clear away the forest and allow your avatar to explore the building, all bets are off. Bad things may happen. In the remainder of this video, I will go over the overall structure of the program, the new classes I have developed, how the player can interact with the environment. This will include how to have a conversation with an NPC, and finally, how to train a dragon, or at least how to have an aggro NPC chase a player and pick a fight with them. Let's get started. The overall structure of the program. As you can see, this program is made up of several modules. The main.py module tells us where to begin program execution and makes sure that all and only the data we want to enter into the program is entered. I'll talk about that in more detail in a moment. MyClasses.py is the module I use for the main class of the program, class game. I think of the game class as an umbrella class because all the other classes run within it. The graphics fauna module contains classes that have the ability to move, classes like the player class as well as the NPC class. As you might expect, the graphics environment module contains those classes that specify the environment. Many of these classes are either changed or brand new. They are the actions class, the triggers class, the events class, the obstacles class, and the walkables class. If that sounds like a lot of classes, don't worry. The actions and triggers classes have nearly identical structures, as do the obstacles and walkables classes. The environment class is an umbrella class for these other classes. I'll go over all that in more detail in a minute. The inventory module contains the inventory class, which is an umbrella class for the weapons and consumable classes. I won't say much about these classes today, but I expect to spend some time on them in the next tutorial. The dialogues module contains all the dialogues I use in the game, plus a few others. The utilities module contains all sorts of functions that don't need to reside within a class. Finally, the constants module contains, well, constants. I like having the constant values all in one place where I can easily access them and change them. Okay, there is a lot to go over and I don't want to get bogged down in minutiae, so I'm going to go over the code fairly quickly, although I will slow down when I'm going over something especially interesting, like how to train a dragon. Let's begin at the main function in the main module. As you can see, the program requires 4 items of information. The player name. At the moment, the only valid player name is Henry, but this will change in the next version. The zone name, the map name, and the profession of your character. At the moment, I have only implemented one profession, that of warrior. I made sure that each of these values is valid to the extent that I can. We will be using these values throughout the program, so I store them in their own file, user data text. There you can see the file system with that file in it, and you can see the contents of the file. I save this new data to usersdat.txt by calling the function setUserData in the utils module. When I wish to access this data, I call getUserData. That's pretty boring and maybe obvious, but I felt like I should go over this. I won't step through those functions, getUserData, setUserData, but if you have questions about any particular function or bit of code, please do leave a comment and I'll get back to you. One thing to note is that, for convenience, I reset the player data every time the game is run. If I didn't do this, then the player would have items in their inventory they shouldn't, and triggers and actions would not be executed in the correct order. I won't step through the code I use for the starting dialogue. I've disabled character creation as well as character modification, though I will implement these in the next version. Now let's look at the function beginGame. The program starts executing when beginGame is called. As you can see, this is where the main object variable, mygame, is created, the game data is read, and the main loop of the program is then executed. Now let's look at the new classes. As I mentioned, most of the changes I made to the program are in the graphics environment module. Note, I'm not going to go over any of the inventory classes, for instance, the consumables class, the weapons class, in this video, since I don't use the player's inventory all that much. I'll talk about the inventory classes in the next video. If you have any questions, please leave a comment. As I mentioned, I've added 3 new classes: triggers, actions, and events. Additionally, I renamed and reorganized the old environment classes, Class Walkable and Class Obstacles. As the names suggest, I've classified tiles according to whether the player can walk over them. In a moment, I will look at these classes in more detail. In preparation for that, though, I want to take a look at the structure of the files that store the environment data. Here you can see the contents of the zones directory. Each subdirectory is the name of a particular zone in the game. We have played through 2 of these zones, Dark Alley and Green Lawn, while a third, Swindon, is under construction. Now let's look at the Dark Alley zone. The files. Here are the files that generate the Dark Alley zone. As you can see from the screenshot of the files, there are 4 maps in this zone: Map 00, Map 01, Map 02, and Map 03. Each of the map directories is structured the same way, so let's look at the Map 01 directory. As you can see, each map is made up of 10 files and 1 directory, texts. In what follows, I will talk about each of these files. Let's start by looking at a map of actions and then at the matching actions.txt data file. Actions files. This is what an action map looks like. Each 2-character combination, and as you can see it's separated by semicolons, is the name of a tile and consists of a letter and a number. This map tells the program where each file needs to be positioned. It gives the X and Y coordinates. This file is paired to a data file, actions.txt. Each element in the map is linked to the items in the data file by the name of the file, for example, W0, L1, and so on. As you can see, each record of the actions text file has 8 fields: name, command, image display, data, inventory condition, game condition, dialog text, and comment. The command, in this case load map, is paired with an else-if statement in the doActions function that we will look at in a moment. The image display field contains the file name of the image we would like to display. The data field contains information about what the program will need to do. In the case of load map, it contains the names of the zone and the map to load. Other times, for instance if the command is find item, then the data field will contain the name of the item to be put in the player's avatar's inventory. We will look at the inventory and game condition fields in more detail in a moment, but basically, if a condition is present, for example if a character must have a red amulet in their inventory or a certain conversation or quest needs to be completed, then unless that condition is met, the action will not execute. The dialog text is just what it sounds like. This is the text that is displayed when the player interacts with the action by pressing the H key. The comment is just for the programmer's benefit. It has no game significance. Now let's look at trigger files. Triggers are like actions except that a trigger doesn't contain a visual component. As you can see, there are 6 fields in a trigger: the name field, the command field, the data field, the inventory condition, the game condition, and the comment field. These fields are all the same as for an action, so I won't go over them again. Events files. In the current version of the program, I only use an event in map 01 of the Dark Alley zone, but here's what that file looks like. Events are simple things. An event only has 3 fields: an index field, a condition, and a value. For instance, after the player successfully completes a conversation with the NPC, Old Ben, this is recorded in the events class and the condition is set to true. Obstacles file. Now let's look at the obstacles map file. As you can see, like the names of action and trigger tiles, the names of obstacle tiles are made up of a combination of a character and a number, with, of course, the exception of the empty tile, which is represented by 2 dots side by side. The numbers on the margins, the ones that run from 0 to 11, are there simply to make it easier to read. They are stripped off when the program reads the file along with the leftmost 3 characters. By the way, as the class names suggest, the player cannot walk over an obstacle tile. So now let's look at the walkables file. Here is the map for the walkables class. This file is read in the same way as the object file is. Each tile name, for example D1, D2, and so on, gives information about a tile to be displayed and which a player can walk over. Now let's look at the NPC file. The NPC map file shows the positions of the NPCs and of the player. I could have made a separate file for the player, but there didn't seem to be a need. If that seems like a lot of information, don't worry. There is a lot of repetition in the code, and everything will make more sense when we look at the classes that use the data. Let's do that now. The classes. Let's start by looking at the class actions. All the classes that read in map files read them in the same way. For example, the readData function in the actions class reads in a map file that strips off the first 2 lines and the first 3 characters. Here we look for any and all files that are not empty, that is, lines that are not represented by 2 dots. When this class reads in the data, we open the text file, and I'll put that up on the screen for you again. It looks for the correct record, and then it grabs the appropriate values from that record. Here's that code. We will look at other aspects of the actions class as they are used to, for example, pick up wild strawberries or put amulets in a player's avatar's inventory. Now let's look at the triggers class. I'm not going to step through the triggers class since it is very similar to the actions class, with the exception that a trigger does not have a visual component. Class events. Here's a screenshot of the events class. As you can see, it is a very simple class. Okay, moving on to class obstacles. The obstacles class is one that I've used before, but I've renamed it and reorganized it. As you can see, I use it to read in map data in the same way I did with the actions class and the triggers class. Here, though, there is no corresponding obstacles text file, though I will lightly include this in the next version, so all the information about the various tiles is given in the program itself. This isn't ideal because if a change needs to be made to a tile, then a change must be made to the program. Now let's take a look at class obstacle. That's all fairly straightforward. In the rest of this video, I'm going to talk about 2 things. First, the ways in which the player can interact with the game environment. In this section, I will also talk about how I implemented the player's conversation with the NPC Old Ben. Second, I will talk about how to implement an NPC that will chase a player and then pick a fight with him. So this brings us to section number 4, the player's interactions with the environment. When the player presses the H key, the Handle Events class in the My Classes module detects it and checks for 2 things. First, whether there is an NPC on the tile the player currently occupies, and second, whether there is an action on the tile. Let's look at each of these. We will look at the detection of actions and triggers first, because they are less complex. So this brings us to section A, is there an action on this tile? If the program detects that the H key was pressed, then the function, there is an action on this tile, is called, and we hand off the player's X and Y coordinates to it. Here is what that looks like. We try to retrieve an action with the same coordinates as those of the player. If none is retrieved, then no action is on that tile and we return false. If there is, then we return true. If there is an action on the same tile as the player, then the function conditions passed that lives in the environment class is called. Here's that bit of code. If the condition for both the inventory and the game is any or none, then no conditions have been put on the execution of this action, and so we say that the conditions have been passed, and we return true. But if the inventory condition is neither any nor none, then it means there is one, and we need to check to see if that item is in the player's inventory. If it is not, then that condition has not been fulfilled and we return false. On the other hand, if the item is there, we do not return true yet because we haven't checked the game condition. Next, we check to see if there is a game condition, and if there is, whether it has been satisfied. If there is no condition, then we return true. If there is a condition and there is a matching event, then we return the value of that event. If the event is false, then the condition has not been satisfied, but if it is true, then it has. Now all we have to do is execute the action. First, we get the action, then we call self-do-action to carry out whatever the command or purpose of the action is. Here is that code. The most straightforward of the commands is load map. We do this all the time. All that is required is to save the player data, save any changes the NPCs have gone through, get the zone name and the map name from the action, save that information into the user info text file, and then read everything back in. That is accomplished by calling the game function readData, and that's it. Now let's look at find item. Here, whatever item is specified in the data directory will be grabbed and placed in the player's inventory. For example, the following data is in the actions text file in the first map of the Green Lawn Zone. So we look at the data field and find that an item with the name Wild Strawberries needs to be placed in the player's inventory. The way the program is set up, I don't actually need to get the item. I just pass along the name of the item to the add item by name function in the inventory class. I've put that up on the screen, and as long as the name I've passed the function is either a list of consumable goods or weapons, then it is added to the player's inventory. I'm not going to say too much about this here. We will go over it in more detail in the next tutorial when we visit the first town, Swindon, and I introduce buying and selling goods, accepting and turning in quests, and so on. In any case, we are almost finished examining what happens when a player triggers an action. After we finish up in the function goAction, we come back to handle events, and the following code is executed. Because it would be odd to continue seeing a strawberry bush after it had been picked, I removed the action from the actions class, so it will no longer be drawn to the screen. For this to take effect though, I have to reinitialize the Pygame sprite group. Then we exit out of the function. So far, the only actions I have implemented are load map and find item. If the command was something else, an error will be raised. Okay, that's what happens when a player comes across an action. Now let's take a look at what happens when the player walks onto a tile that has a trigger on it. The last line of the handle events function in the game class is check for trigger. This function is called every tick of the clock, regardless of anything the player does. Because of this, I could just as well have put it in the update function. We will look at that in a minute, but it feels right having it in handle events. When you're coding your program, please feel free to reorganize things in a way that makes sense to you. In any case, here is the code for the function check for trigger. As you can see, the first thing I do is check to see if any triggers exist in this map. If they don't, then I know the player hasn't stepped on a trigger and I exit out of the function. If there is at least one trigger though, I ask the program whether there is a trigger on the tile the player is on. If there is one, so if current trigger is not none, then I hand this object off to the function doTrigger to carry out whatever the trigger's command is. I put the code for the doTrigger function up on the screen. Let's look at the load map command first. The logic here is exactly the same as for actions, so I won't step through it. If you have any questions, please do ask. Before we look at how we process the command showText, let's look at the data file that showText draws from. As you can see, the data file contains the text, text1. If you take a peek at the texts directory, you will see the tile text1.txt. We want to display the contents of that file to the player. So first we open the file. As you can see, we use the data field to form the name of the file we want to open. Then we form the file path. Then we simply parse the data in the file and display it to the player by using a text dialog object. Afterwards, we reset the graphics display, and that's it. By the way, I'm not going to go over the other triggers you see here, change NPC passive and change NPC aggro, because I developed them to provide bonus content at the end of the program. If you want me to step through them, let me know in the comments and I'll include that in my next video. Now, finally, let's turn to look at what happens when a player chooses to interact with an NPC who is on the same tile as the player's avatar. First, we determine whether there is an NPC on the same tile as the player. If there is, then we call the NPC encounter function. The code that you see there is simple error checking. It should never happen that this function is entered and there is no NPC on the tile, but I like to eliminate every possibility I can. It makes debugging easier. Next, we have an interaction with the NPC. For convenience, I put this function in the NPC class. Let's take a look. In the present version of the program, the player never needs to initiate a fight with an aggressive monster. The monster will always initiate a fight with any avatar on the same tile as itself. If the NPC, though, is not a monster, then a dialogue pops up. Two new classes, Dialogue Speech and Speech. The Dialogue Speech class is all about displaying information, while Class Speech is all about processing the information. Let's look at Dialogue Speech. The important field here is conversation, because we use it to hold the speech class. Here is the read data function in Dialogue Speech. The lines I want to look at are these. Conversation equals speech, and then I'm handing it the NPC name, and conversation, read data. So let's go over to the speech class and take a look at that. I've put that code up on the screen there. The speech class is another brand new class, and this class depends on another class, speech instance. To see the relevance of these classes, let's take a peek at the data files the speech class reads in. So this, what you're seeing on the screen is from the text file named Old Ben. There are 8 fields here, an index, a prompt, 3 choices, and 3 responses. Let's go over these. As the name suggests, the prompt gives the player something to respond to. In this case, the player is asked to choose between the 3 choices given. Depending on the choice they make, that is, depending upon whether they choose 1, 2, or 3, the NPC responds with response 1, response 2, or response 3. Notice that at the end of each response is a little tag, either continue, end game, or end conversation. The structure of the conversation, linear rather than branching. This is a very simple conversation with a linear structure. There is no branching. But that said, implementing a branching structure wouldn't be too difficult. Now, let's look at the code again. Specifically, let's look at the events function, since that's where everything happens. The first thing the player does is make a choice. So let's begin our examination of the events function by looking at how the program responds to the player pressing either 1, 2, or 3. The first thing we do is tell the class there is a response to draw, so we set draw response to true. Next, we get the appropriate response for that choice. The program knows which response is appropriate because we keep track of which record or card is being displayed by the value stored in index, and by specifying which response we are interested in accessing on that record or card, 1, 2, or 3. Here's the code for getResponse in the speech class. Here I use the fact that the way I'm storing the data in the speech class is a list to directly access the element I want to return. If you look at the init function in class speech instance, I've put the relevant bit up on the screen. As you can see, I store the responses for each record or card as a list of 2 elements. The first element contains the NPC's response, that is, the text that will be displayed to that player, and the second element contains one of 3 text strings, continue, end conversation, or end game. This list of 2 elements is stored in the response list variable in the events function of the dialog speech class. The second really very important bit of code to go over, and this will be the end of discussing how to have a conversation with an NPC, I promise, is the code that is executed when the player presses the return key. Here it is. What this is saying is that if the second element of the response list is endgame, then set the variable we are going to return, the message variable, to that value and set keep looking to false. So the while loop in main will end and the value will be returned to the calling program. And of course, it works similarly for the other 2. After this, the index gets incremented. Next, we check to make sure that the value in index isn't larger than the length of the conversation. If it is larger, then, again, the message to return is set and keep looping is set to false so that the main loop will end. Of course, this can easily be thwarted by the player. For instance, if a correct response is entered and then the player keeps pressing return, they will successfully complete the conversation. Just FYI. That is all I have to say about the conversation. Now, let us turn finally to how to train your dragon. A function is the solution to a problem. In this case, the problem is how to get an aggressive NPC to detect the player's avatar and move towards them. We haven't looked at the update function yet, and that's where I've put the code that drives an NPC to commit player side, as opposed to homicide. Anyway, let's go over that now. Hi. I had to re-record this part to correct a flaw in the original recording, and I'm just saying this to say sorry if I sound different. As you can see, in the first line of the update function, we look for the closest aggressive NPC, in other words, a monster. Let's take a look. We hand off the player's coordinates to this function, and then, after some error checking, we calculate the distance between the player and an NPC. We then determine whether that distance is less than the closest distance we have measured to date. If it is, then that distance replaces the value held in the variable closest distance, and the monster closest variable is set to that of the current NPC. When the for loop exits, if the monster closest variable is not none, then we return the contents of that variable. Otherwise, we return none. This brings us to the update function. Now that we have the aggro NPC who is closest to the player's avatar, we check to see that it is not dead and that it is not aggressive. Next, we move the selected NPC, the monster, toward the player. Let's take a look. If the player's X and Y coordinates match those of the NPC, then the NPC has caught the player, and all we need to do is return true. But if the x-axis of the player matches that of the NPC, then we move the NPC closer to the player on the y-axis. Similarly, if the y-axis of the player's avatar and the y-axis of the NPC match, then we move the NPC closer to the player along the x-axis. Finally, if neither of the axes match, then I randomly choose an axis, either x or y, and then move the NPC closer to the player along that axis. By the way, this algorithm has trouble navigating around obstacles like walls and counters. I have an idea about how to improve it, but I will leave that for the next version. Okay, we are back in the update function. Now we check to see whether the NPC is dead. If it is, then the NPC's image is updated to show that the NPC has died. Otherwise, if the NPC and the player are both on the same tile, then we call the dialog fight class and run the main function in that class. I will not go over that code here since I covered it in my last video, although I'll put a link to that video in the description. After the fight is over, if the player is dead, then we set the NPC's aggro level to passive. We also assign the appropriate image to the image variable in order to show that the player has died. We ask the player if they would like to play again. If they do, then we reset the player's hit points, copy over the player's original files, and save the NPC's data. Another thing I want to do is reload the zone at the beginning of the previous map. If it so happens that the map the player's avatar is currently on is map 00, then map 00 is returned. Otherwise, the previous map is returned. So if the player is on map 01, map 00 will be returned, but if the player is on map 00, then map 00 will be returned. Next, we save the new map name in the user data text file and then, naturally, read the data in again. And that's it for the update function. One more thing, I had to slow down the NPC or he caught my avatar too easily. As you see, I put a line in the main loop of the program that calls sleep every clock tick. This forces the NPC to wait half a second between moves. You might need to adjust this for your computer. If the NPC catches the avatar too easily, perhaps slow things down. On the other hand, if the avatar gets away too easily, then speed things up. I have attempted to communicate an enormous amount of information in this tutorial, so if you have any questions, please leave a comment and I will get back to you. Thank you for listening. If this video helped you in some small way, please leave a like, and if you would like to be notified when I publish a new video, please consider subscribing. It really does help the channel. Now that I have developed something of an overall structure for the program, I hope to upload tutorials more often. Thank you for your encouragement as well as your patience. Good coding. I'll talk to you again soon.